So let's come back to the 2019 Math Method Exam 2, Section B. There are 5 extended response questions, totally worth 60 marks. So question 1, 11 marks. Around this question, we are talking about f of x equals to x squared times e to the power minus x squared. So part A and B, well, we have 4 subparts. They are talking about the derivative stationary point at the origin, the maximum value possible, and the values of x for the maximum to occur. And also, we would like to shift this graph. Let's say shift this graph by d units up or down such that it's always a negative or below the x-axis. So actually, we need to use the CAS calculator consistently. So let's come back and look at the possible calculator approach. Well, for each extended response question, the best practice is to press Control up, insert a problem. So for each individual problem in a document, you are not getting some variable clashes or whatsoever. So let's say we start with f of x is assigned to x squared times exponential minus x squared. EXP means e to the power something in that bracket. So you could get a shift minus f of x. And that is, f dash of x. There is no need to factorize or whatsoever. Now, state the nature of the stationary point on the graph of f at the origin. Well, we have been told x equals to 0 is a stationary point, and later we will verify that through the graph. We can actually take the second derivative and slot in x equals to 0. You get a 2. That means the second derivative value is greater than 0. That's why it's concave up and it's a local minimum. And then the maximum value will occur. Let's say if we slot in the graph, f of x, and we may zoom in a little bit. You can see there are 2 stationary points. Each side of the y-axis, they are 2 local maxima or global maxima, okay? And this value is not an exact value, so the maximum value needs to be exact at a -1 or 1 via the graph, okay? Or you could try, let's say, f maximum command. So let's come back. F max, f of x, comma x, x equals to -1 or x equals to 1. So f minus 1 is e to the power -1. F of 1 is e to the power -1. Finally, if we want to get this graph shifted such that the shifted graph downwards is always negative, we would have to, let's say, use f of x minus exponential -1. But the problem with f of x minus e to the power -1, well, we still have 2 points. They touch the x-axis. 0 are not negatives, okay? So we'll have to make sure whatever values of d I take, it has to be even less than minus e to the power -1, okay? It has to be lower than that, right? So let's come back to the CAS calculator and write down the answers. F dash of x is, copy from your screen, let's say 2x, subtracting 2x cubed times e to the power -x squared, okay? Something along these lines. And nature of the stationary point, say f double dash of 0 equals to 2, greater than 0, concave up, local minimum. Find the maximum value. Well, you could draw a diagram like this. technically, it has a long-term asymptote y equals to 0, but it does touch the x-axis at 0, 0. At x equals to plus or minus 1, f max equals to f minus 1 equals to f1. They are symmetrical, e to the power minus 1, okay? Or 1 over e. Need to shift f of x down by more than e to the power minus 1. Shifts down by more than that. Therefore, d has to be lower than e to the power minus 1 with a negative, okay? Or let's say d is an element of negative infinity to negative e minus 1. It has to be an open circle, okay? Or round bracket. Find the equation of the tangent to the graph of f at x equals to minus 1. Well, we know there is a turning point. So if I say, all right, I draw a quick graph according to what I just obtained from my cast. This is minus 1. This is e to the power minus 1. It has a horizontal tangent at this point, okay, which also touches the curve at a 1, okay? So the equation means you have to write a y equals to e to the power minus 1. If you don't have the y there, you just write e to the power minus 1. You don't get a mark, I suppose. And find the area enclosed by the graph of f, and the tangent to the graph of f at x equals minus 1. So the bounded area will be, this bit, corrected 4 decimal places. I suppose if you use your CAS calculator, there are various options you could write. So we use upper. This is your upper minus your lower between minus 1 to 1. So the area equals to, from minus 1 to 1, e to the power negative 1, subtracting f of x. Even if the top line is a horizontal line, it still counts as a function, okay? It still counts as a function. And you can now use your CAS calculator to evaluate. From my CAS calculator, this should be, let me check out, minus 1 to 1, exponential minus 1, minus f of x dx. 0.3568. Okay, so square units. Of course, you could use some other versions. Let's say 2 and 2. Let's say 0 to 1, e to the power minus 1 minus f of x dx, or even use, let's say, rectangle. The rectangle subtracting, let's say, 2 lots of the symmetrical area under the curve. That gives you, let's say, 2e minus 1, subtracting 2 lots of 0 to 1, f of x dx, something like that. But all of them will give you, let's say, the same answer, 0.3568, etc. All right, part D. Let capital M, small n be a point on the graph of f, where m is between 0 and 1. And find the minimum distance between m and the point 0e, and the value of m for which this occurs, correct to 3 decimal places. So I suppose we can get an idea of what happens through our CAS calculator. First of all, if I just look at, let's say, let me delete this graph. And let's get a 3 here. Let's get a minus 1 here, something along these lines. Let's get a 1. Okay. So where am I? This is like 0e, okay? And somewhere along the curve from 0 to 1, let me show you a line segment. It's starting from 0 to e. Could be here, could be here. And there is a particular point along the curve such that the distance from 0 to e is the shortest possible, okay? So let me just get the segment here and show you what happens. So pretty much we want to find out the minimum distance. And this location can be represented by, if I'm not mistaken, this will be n, comma, let's say m, comma, f of n, okay? And we can actually form a distance function through these 2 points. So let's use some Pythagoras. M minus 0 squared, f of m minus e squared. Let's call this distance function m is defined to m minus 0 squared plus f of m minus exponential squared, okay? And what I'm trying to do is minimizing this distance. So you either solve the derivative of that with respect to m equal to 0 for m, given 0 less than m less than 1. You get that value, and then you will get distance of that. And the distance correct to 3 decimal places is 2.511, okay? So that's a 3 marks question, I suppose. You need to show some methodology like formulation and identifying the m value, because the question asked for the m value correct to 3 decimal places as well. And finally, you need to state the minimum distance which occurs for this particular m value. Alternatively, you can use f minimum command. But you have to specify the domain restriction because m goes from 0 to 1. Okay, press Control Enter rather than press Enter. This is one possible method. Alternatively, you may recognize if it's the shortest distance, this has to be the perpendicular line. This has to be the perpendicular line to the curve. So you can say the gradient at a point M multiplied by the gradient of this line segment is -1, which is also possible. Say, you can solve shift minus M, f of M multiplied by, let's say, f of m subtracting e divided by m minus 0 equals to -1, comma m, given 0 less than m less than 1. And you still get that value, but you still need to form that distance whatsoever, okay? So inevitably, you have to form this distance. All right, let's come back and write everything out. Okay. Alternatively, to determine the value of m, you could say, all right, perpendicular gradient for shortest distance. Let's say f of m minus e divided by m minus naught multiplied by the derivative f dash m equals to -1. So m equals to 0.783. And then you still need to get the shortest distance by the same method I demonstrated, okay? And one final thing, I would say highly recommend you to use the unrounded value for the substitution here, even though you state the m as your final answer to 3 decimal places. I'm not going to just sub in 3 decimal places. I will substitute everything into the distance function here, okay? So that is question 1. And now let's move on to question 2. Now we are looking at an amusement park. It's planning to build a zip line above a hill on its property. So the hill is modeled by, actually I would say the top edge of the hill is modeled by this cubic function from x equals to 0 to x equals to 30. And x is the horizontal distance in meters from an origin, and y is the height in meters above the origin, as shown in the diagram. Well, the question doesn't provide you a function notation, so I probably would say specifically let f of x equals to 3x times x minus 30 squared divided by 2000, okay? Along something like this, along the line like this, and find dy dx. Well, this f dash of x will be equal to dy dx. And then you can just say, use your CAS calculator and define everything. Again, I'm going to insert another problem and be consistent with my function notations. So 3x times x minus 30 squared divided by 2000, okay? And actually, if I would like some sort of, domain restriction, I could put a given that 0 less than or equal to x less than or equal to 30, okay? After this f of x thing. And once we get the derivative, we're actually able to get something like this 9 times x minus 30 times x minus 10 divided by 2000. But then the endpoints will be excluded from, originally it was an equal sign here and an equal sign here, but after differentiation, the gradient doesn't quite exist at each endpoint. Okay? So just write that out. And then we'll have a look at the next part. The next part is actually an interesting one. Okay? It created a lot of debates amongst teachers and students. What happens is the question wants me to state the set of values for which the gradient of the hill is strictly decreasing. Well, state a set of values of what? I would say of x, okay? This was the intention. And I would like the gradient of the hill to be strictly decreasing. So this is an interesting part. For strictly decreasing, we would like the gradient of the gradient less than or equal to 0, while the overall restricted domain for the gradient is from 0 to 30, okay? We need to combine these, grand domain for the derivative, the domain of the derivative function, as well as the second derivative less than or equal to 0. So we need to use f double dash of x less than or equal to 0 and 0 less than x less than 30. I suppose that's the intention of the writer. So let's have a look at the document. It's handy that I've defined f of x together with the domain restriction. So I will just solve the second derivative, f of x, because I want the gradient to be strictly decreasing rather than the original function to be strictly decreasing. So that gives me 0 to 20. Notice that 0 is excluded in the domain, all right? So that is the intended answer, I suppose, from a 0 less than x less than or equal to 20. So let's come back and look at the rest parts. Okay, the cable for the zip line is connected to a pole at the origin at a height of 10 meters, and it's straight from 0 to A, where A is between 10 and 20. The straight section joins the curved section at a capital A, comma B. The cable is then exactly 3 meters vertically above the hill. Well, according to this diagram, I would say the cable, this curvy bit, is a translation of 3 units up, 3 meters up from the hill, okay? And state the rule in terms of x for the height of the cable above the horizontal axis for x between A and 30. So I could say cable of x equals to f of x plus 3. Or let's say cable of x equals to 3x times x minus 30 squared divided by 2000 add 3, okay? For that domain from A to 30, okay? And then we say find the values of x for which the gradient of the cable is equal to the average gradient of the hill for x between 10 and 30. I would say the gradient of the cable is c dash of x. And then I would say the average gradient between 10 and 30 is like c of 30 subtracting c of 10 divided by 30 minus 10. Because we have defined this c here, we can then use the c of x for the next part without actually writing, the explicit derivative form. So let's come back to the CAS calculator and see what's happening. Define c of x equals to just this bit plus 3. And solve shift minus x cx equals to c of 30 minus c of 10. 30 minus 10, comma x. And 10 less than or equal to x less than or equal to 30. So you actually obtain these two values, okay? These two values. Just be very careful when you're transcribing everything. Make sure you write the vinculums correctly and don't drop out the negative sign easily, all right? So based on the domain restriction, we have two solutions, okay? Two solutions. The question didn't say any rounding instructions, so we need to keep the exact values, okay? Well, an interesting observation is that if we use the, let's say, f of x, if you use the actually f of x, you'll still be able to get, let's say, the same answer, but that's not quite right in terms of using a correct function. The reason why we get the same thing is because c of x just had an extra 3. So after differentiation, the 3 disappeared. Also in the subtraction process, C30 had a 3 there, C10 had a 3 at the end. So subtracting the 3, they canceled out. That's why you are generating the same set of two values, but it's not quite the correct equation. So you need to be very careful with that, okay? And now, coming back to the question itself, let's move on and have a look at next few parts, okay? One last thing. Actually, state the rule in terms of x. Well, if the question says in terms of x, it must be explicitly in terms of x. So not just writing f of x plus 3. Maybe let me just elaborate here. This is in terms of f of x. This thing is purely in terms of x. So I would say this one should be the correct answer, okay? The whole thing, the rule, okay? State the rule, right? And yep. And yep, let's just put an extra thing here. Solving for x between 10 and 30. Something along these lines. All right. The gradient of the straight and the curved section of the cable approach the same value at x equals to a. So there is a continuous and smooth drawing at a. So state the gradient of the cable at a in terms of a. Well, because we defined this c of x at a point a, we have a bracket c of a, okay? And at this point, this is 0, 10, okay? So we actually, for smooth drawing, we could take the derivative from the right-hand side, take c dash of a from right-hand side of this point, and then figure out the straight line gradient from 0 to 10, 0, 10 to a comma c of a from left-hand side. So we'd like, you know, the gradient equal to each other. And there is a smooth drawing whatsoever. Look, the gradient of the cable at A in terms of A. So it has to be fully in terms of A. Now, what I'm going to do is I'll try to find the coordinate of A by equating the gradient, like the A value, then sub into C of X, which is C of A. So let's say we could get one version of the gradient is C of A subtracting 10, A minus 0. So you could get something along this line. This is one possible expression. And then you could take a derivative C of A. Well, this is also another expression, and calm the norm. Well, something along this line, okay? So then to find the coordinates of A, well, you need A and B values correct to 2 decimal places. So let's solve a curly bracket. We don't need to write out, you know, for the working out, we probably don't need to write out the explicit form, as long as you can convey the correct mathematical meaning. This is equating the gradient from left, from right, same gradient value. And once we figure out the A value, we sub that into B equals to C of A, comma, B. And just notice, on the previous page, the question says A is between 10 and 20, 10 and 20. So you need to say 10 less than or equal to A, less than or equal to 20. And we are trying to find each value correct to 2 decimal places. So what you're going to get is 11.1157, 8.94606, etc., etc. But you only need to round them to 11.12 and 8.95, okay? All right. And the last part of part E was to find the value of the gradient correct to 1 decimal place. So you probably can just take the derivative here and slot in your A value you just obtained. That is minus 0.094847, etc., etc. Okay? So let's just come back and write out something. If left side, we can use gradient equals to C of A subtracting 10 divided by A minus 0. That gives me something like 3A to the power of 3 minus 180A squared plus 2700A minus 14000. Well, quite a tedious expression, okay? There are so many other, equivalent expressions. If right side, you are taking C dash of A, that's equal to 9A squared minus 360A plus 2700 divided by 2000, okay? And find the coordinates of A with each value corrected to decimal places. Equal gradient. So let's say C of A minus 10 divided by A minus 0 equals to C dash of A. So we say solving for A is approximately 11.12, etc. Okay, and you can sub in the A value and get the B. Okay. So the coordinates of A, sorry, is 11.12, 8.95, etc. Okay, 2 decimal places. All right, and now for the last part, gradient equals to C dash 11.11574. And then that's minus 0.09 something, 481, etc. 1 decimal place, that is approximately minus 0.1, okay? Correct, 1 decimal place. So that's the end of the question 2, okay? And let's have a look at question 3. Continues over page. So this is a typical, simple application of a circular function and modeling with some calculus components or elements embedded. During a telephone call, a phone uses a duotone frequency electrical signal to communicate with the telephone exchange, so 0, 1, etc., etc. The strength f of a simple duotone frequency signal is given by the function f of t equals to sine pi t over 3 plus sine pi t over 6, where t is a measure of time and t is greater than or equal to 0. Part of the graph of y equals to f of t is shown below. So you can see 0 to 12, 12 to 24. What I'm saying is now if you want the period of function, the period means the function has to repeat the same pattern over, a certain span, horizontal span. For example, if you look at this part, it's not just enough to get, 0 to 6, because when you shift the graph by 6 units, it doesn't repeat itself, okay? And therefore, you probably need to go a little bit further, say from 6 to 12 as well. So now if you are pushing this part of the graph by 12 units to the right or 24 units to the right, etc., etc., the graph will repeat itself, okay? And the period is 12. Well, if you wish, you could say the t doesn't give you it's a measure of time, but it doesn't give you the unit, say seconds, minute, or whatsoever. So you just need to state p equals to 12, period equals to 12. And find the values of t where f of t equals to 0 for the interval from 0 to 6. So observation from the graph 0 for 6. Just say t equals to 0 for 6. You don't even need to use your CAS calculator. Okay, find the maximum strength of the duotone frequency signal corrected to decimal places, and then find the area between the graph of f and the horizontal axis for t between 0 and 6. So I'll talk through part C and part D together, and also I will use some integration stuff later. Now, because this is question 3, I'm going to use the control up, press menu, insert a problem. What I'm going to do is I'll define f of t. F of t control template button, sine of pi times t divided by 3 plus sine of pi times t divided by 6. And you probably could verify your period. How do you verify the period? Say your period is 12. You could use t minus 12 or t plus 12 equals to ft, which is true. Excellent. That means your period has to be 12, the minimum positive period. The maximum strength, if you plot a graph here, I don't need so many split screen. I just need 2. Let's choose layout 3. Okay, so let's put a graph here, and how about we use -6, and we use a 24 here. Let's use a 2 here. So let's use f of x. So you can see every 12, let's say 12 minutes, every 12 minutes, the graph will repeat itself. You will have a highest point here. Analyze graph, maximum. Well, just distinguish between your t value. Well, in this case, it's labeled as x value, but anyway, this is what the question wants you to find, okay? The question doesn't ask you for the value of t, but it asks for the maximum strength of the frequency signal. So it's asking for the highest y value, okay? So it's 1.76, corrected to 2 decimal places. So you need to specify f max equals to 1.76, corrected to 2 decimal places, okay? And the area between the graph and horizontal axis for t goes from 0 to 6. That means you need to find this positive area, subtracting this negative area, okay? Well, there is an issue if you want to, if you want to take a cut the corner, say 0 to 6, f of t dt. That will not give you the correct answer. You know what I'm saying? This is the wrong answer because it has been compensated by a negative part. And some other student may want to cut the corner, say we want the absolute value of that. Well, if you were trying absolute value of that, even if you press Control Enter, it doesn't give you, some desired result. So you have to go from the first principle, like the positive bit is 0 to 4, f of t dt, minus 4 to 6, because 4 to 6 ft dt gives you a negative signed area. Then you're subtracting a negative signed area, and that gives you 15 over pi, okay? So this is something you also need to work out. So the area is actually 0 to 4 ft dt, subtracting 4 to 6 ft dt, and that equals to 15 over pi. And the question didn't specify any rounding instruction, like correct to 2 decimal places or whatsoever. You have to write the exact values, okay? Exact value is 15 over pi, nothing else. So let's come back to, writing space and take a quick look at the next 2 parts. Okay, another thing here, because I'm using the original PDF version provided by VCAA, the original question was using a matrix transformation notation, but in the 2023 to 2027 study design, it should read as T R squared mapped to R squared, comma, TXY equals to AT plus C, comma, BY plus D, because there is no letter X in the question. The horizontal coordinate should be a T, okay? Anyway, A, B, C, D are real numbers. So we need to apply, a sequence of transformations such that this thing here plus this thing 2 to 0 GT. Well, the reason why they had a large number at the bottom is because it's actually minus 0 to 2 G of T dt at 2 to 6 GT dt has the same area calculated in part D. So we would like this thing also equal to 15 over pi, okay? So what sort of transformations would I apply? Well, first of all, the integration is along the t-axis or the horizontal axis. Definitely, I would say we don't need any vertical translation. We don't need any vertical translation. And then we start to think about, okay, how do we match the area? You can see in the original exam booklet, they provide you a relatively large, let's say, relatively large diagram. Right. But it only provides you, let's say, some sort of positive bit. So maybe, well, from the diagram, we know the large chunk originally was integration 0 to 4 f of t dt. This is a larger chunk, large hump. And a small hump, if we want the absolute area, it was like minus 4 to 6 f of t dt. And it has the same area as minus 0 to 2 gt dt at 2 to 6 gt dt. So that means this is also the large chunk. This must be the small chunk after certain transformations. There are more than one way to tackle this question. And if you refer to the assessment report, the chief assessor also says other equivalent answers were accepted or similar things like that. So one possible approach I would say is if I, let's say, reflect everything. If I reflect everything by -1, let's say, reflect about the t-axis or horizontal axis, then just notice it's not just like one period. You also have other cycles afterward. Okay? You also have other cycles. For example, let's say a reflection will be suitable, and then if I push all the graphical bits after reflection, how do I make the small from 0 to 2, but we have a negative? It has to lie below the x-axis or t-axis. So see, originally I'm here. If I push by 2 units, that's 4 to 6. Well, but the other one is like 6 to 2 to 6, which is not good enough. So probably I need to push a bit extra to the left. Okay. Once I push everything to the left by, let's say, this was 2 units, 4 units, 6 units. Okay. This is a possible way to tackle the problem. Say you would get, let's say, this bit is negative 0 to 2, okay? And this is gt dt, okay? And this is 2 to 6 gt dt, okay? So how do we obtain gt? Well, from ft to gt, firstly, we did minus f of t. And then next, we could do minus f of t at, let's say, t at 6 units, okay? So through the graphical observations, we could actually say, all right, if we don't dilate at all, A could be equal to 1. If we don't dilate along the horizontal direction, and C is like, because we translate to the left, minus 6. But technically, because the graph has, some sort of, period of 12. Technically, you could put a plus 12n here to cope for the periodicity. And this n value has to be, because it's moving to the left, it's z minus union 0. But to be honest with you, I would say n is all whole numbers. Eventually, they can be canceled out, okay? And the b value, because you reflected about the t-axis, this is a negative 1. It's a negative 1 times y, okay? Negative 1 multiplied in front of y. And the d value is 0. So this is just one set of, possible answers. There are other answers such as you could also use a minus 1 here. This is 1 here. You reflected about the y-axis and then push that by multiples of 12 to the left or to the right, whatsoever, okay? So let me just mark down here. Other possible answers exist. Well, how do we check if our answer works? Probably I could show you something. Well, this is 4.1. Problem 4.1, we have defined f of t. So I could probably add in a note page. Well, this was transformation. Transformation. Let's put in the mass box. Let's say A is assigned to 1. Press enter, and B is assigned to minus 1. And let's say C is assigned, mass box C is assigned to minus 6 plus 12 n, okay? And mass box D is assigned to, let's say, 0, okay? So the transformation overall we applied will be, from 2 to 0. It's a transformation applied to function f of t. So let's say b times f of t minus c divided by a add d dt plus shift plus 2 to 6 b times f of t minus c divided by a add d dt. Okay, so after we applied this transformation to the f of t, this is the resulting function in terms of f of t involving a, b, c, d, 4 numbers. So for example, if I choose a equals to 1, b equals to minus 1, c equals to minus 6 plus 12, and 1, and d equals to d. that calculation actually checked, okay, good, my ABCD value works because it evaluates 15 over pi. If I try a -1 here, that's minus 15 over pi, which is no good, but then we need to adjust b equals to 1. That also gives me 15 over pi. We may want to check with other values, say, how about a 6 here? Well, technically speaking, if you try a 6 plus 12 and 1 here, well, that also gives you 15 over pi. So what if I try minus? You can see this thing doesn't change, 15 over pi, which is also good, okay? So there are other equivalent versions, and this is a quick example of using Notepad to check if the answers you guessed or you obtained using trial and error is correct or not, okay? Okay, so maybe I'm talking too much about some other fancy stuff, but let's move on to look at the last part. The rectangle bounded by the line y equals to k, the horizontal axis, and the lines x equals to 0 and x equals to 12, has the same area between the graph of f and the horizontal axis for one period of the duotone frequency level. That means from t equals to 0 to t equals to 12, okay? So that's for one period. Now, we know one period is 0 to 12, so half period is 0 to 6. Maybe we could work with, let's say, half of the rectangle here, because this is y equals to k. So this bit is 6k. This bit is another 6k. But what I'm saying is, based on our previous calculation, the graph, part of the graph, this is 0 to 4 and 4 to 6. Well, the sum of these two regions will equal to 15 over pi. So if I duplicate another half cycle here, it's like this and that, isn't it? Okay, so that's 12. So these two parts will also give me 15 over pi. Therefore, I would like 6k plus 6k equals to 15 pi plus 15 pi. So half each, you will get, let's say, 6k equals to 15 over pi. Therefore, k equals to 15 over 6 pi, and it simplifies to 5 over 2 pi. Okay? So that is the answer intended, I suppose. A bit convoluted in the wording, but if you drew the diagrams, you immediately recognize what's being looked at, okay? So that's pretty much what we need to discuss for question 3, and then we can just move on to look at the probability question and the last investigative question, okay? So we get our cascade calculator ready. Question for 17 marks, quite a bit. Probability and statistics. The Lorenz bird wing is the largest butterfly in town A. The probability density function that describes the lifespan x in weeks is given by 4 over 625 times 5x squared, 5x cubed minus x to the power 4 from 0 to 5. So the lifespan in weeks is a continuous random variable measured in weeks. And elsewhere, it's just like a 0 probability. So the mean lifespan, you can just define this function and then get the mean lifespan. Okay, and let's say mu equals to integration from 0 to 5. 4x divided by 625 times 5x cubed minus x to the power 4 dx, okay? Something along these lines. And we need to use CAS calculator to evaluate that. In a sample of 80 Lorenz bird wing butterflies, how many butterflies are expected to live longer than 2 weeks? That means your x has to be longer than 2 or larger than or equal to 2 for continuous random variable. It doesn't really matter. Correct to the nearest integer. So it's like 80 butterflies times the proportion of butterflies longer than 2 weeks. 2 maximum is 5. So you actually calculate, a probability, then multiply the probability or proportion by 80 to get the answer. And what is the probability that the Lorentz birdwing butterfly lives for at least 4 weeks? Given that it lives for at least 2 weeks, so we would like probability of x greater than or equal to 4, given x greater than or equal to 2. So this is like probability of x is between 4 and 5 divided by probability of x greater than or equal to 2, less than or equal to 5, okay? It's a conditional probability. Then it's actually looking at 4 to 5 f of x dx over 2 to 5 f of x dx, okay? So you can see there are 6 easy marks if you learned your probability basic concepts. So let's come back to the CAS calculator and do the rest work. Let's insert a problem. Define f of x equals to 4 over 625 times 5x to the power 3 minus x to the power 4. And then shift plus from 0 to 5, x times f of x. You can actually write x times f of x in your response because f has been defined and that gives you 10 over 3, okay? So the mean lifespan is 10 over 3 in weeks. And you need to retain the exact value rather than decimal value. The next part, make sure you calculate the probability so you don't need to multiply this x here. So what you're going to do is multiply an 80 from 2 to 5. And the closest answer is 73.0368. So 73 butterflies. 73 butterflies, okay? And the last part is calculating a ratio between two definite integration. So from 4 to 5, fx dx. And divided by shift plus 2 to 5, fx dx. Correct to 4 decimal places. So the answer is 0.2878, okay? Not 77. Let's say if you're lazy enough to do the rounding yourself, well, this might be a good idea. Round this answer, comma 4. 2878, okay? The calculator will do the rounding for you. All right, let's come back to the writing space and complete the rest of the question. Ten over 3, 73 butterflies, 0.2878. Okay, so last few parts. Bear with me for a second. Okay. The wingspans of Lorentz birdwing butterflies in Terran A are normally distributed with a mean of 14.1 centimeters and standard deviation of 2.1 centimeters. Find the probability that a randomly selected Lorentz birdwing butterfly in Terran A has a wingspan between 16 and 18, correct to 4 decimal places. So let's say W is the wingspan. Normal distribution 14.1, 2.1 bracket square. That's a variance. The convention is a variance here. So I would like to get a probability of 16 less than or equal to W less than or equal to 18. Because the question already used the X, I'm not going to repeat the X for the previously used random variable. For a new random variable, I'm using the new letter, okay? And this will give me, if I'm using the norm CDF command, 16 to 18 from 14.1, 2.1. We actually need to fill in the standard deviation here, okay? So I check through my CAS calculator. That will be 0.1511, if I'm not mistaken. 1150. That's 0.1511, okay? And A Lorentz bird wing butterfly is considered to be very small if its wingspan is in the smallest 5%. Smallest 5% of all the Lorentz bird wing butterflies in 10A. So the lowest 5% is like the tail on the left, okay? 0.05. So we know the middle value or the mean value is 14.1. And we want to find this critical value. That is the greatest possible wingspan for a very small Lorentz bird wing butterfly in 10A, correct to 1 decimal place. So probably could use, let's say, norm CDF minus infinity to C star. And the middle value is 14.1. 2.1 equals to 0.05. Or you could use inverse norm. The left tail is 0.05. The mean value is 14.1 and 2.1. You could either solve the first equation for C, and C is definitely a positive value, or use inverse norm CDF. So let's look at the CAS calculator. You can see now I actually calculate this value already. I could either solve minus infinity to see that norm CDF equals to 0.05, comma C, 10.6, 1 decimal place, or inverse norm, 0.05, 14.1, 2.1. Yeah, pretty much the same thing, okay? Just a few digits off after the 5th or 6th digit, okay? But it doesn't really matter because eventually we just look at, the first decimal place. So the answer is 10.6 for your critical value. And don't round it up, say 10.7, because if you round it up, that will lie within, the non-small region, okay, which is another story, okay? So don't round it up. Just use the normal rounding. 10.6, okay? All right, so let's have a look at the rest parts. Each year, a detailed study is conducted on a random sample of 36 Lorentz birdwing butterflies in 10A. A Lorentz birdwing butterfly is considered to be very large if its wingspan is greater than 17.5 centimeters. The probability that a wingspan of any Lorentz birdwing butterfly in 10A is greater than 17.5 is 0.0527, corrected 4 decimal places. So that actually means you need to use that as your probability of success. So let's call the number of large butterflies L. And it's either very large or not very large. So binomial distribution, N equals to 36 and P equals to 0.0527, okay? If I wish, I could use the norm CDF to calculate the more accurate answer, but I don't think it's necessary because the question provides you this number for you to use, okay? Right, and part F1, we want to find the probability that 3 or more of the butterflies in a random sample of 36 Lorentz birdwing butterflies from 10A are very large, correct 4 decimal places. So actually, 3 or more. L is larger than or equal to 3, less than or equal to 36. So this is using the binom CDF, okay? And let's say 36. Well, you can actually see I try to calculate 17.5 to infinity, and yeah, indeed, correct to 4 decimal places. This value is 0.0527, but we truncated this bit. So use that for your p-value, but if you wish, you could use more decimal places, but not necessary. And a 3 is your lowest value, and a 36 is your highest value. So you will get a 0.2947, okay? 0.2947. And let's see what's the difference between using the rounded value and the exact value. Okay, by a tiny bit, but I would say for your exam convenience, well, because they didn't ask you to calculate the probability of one butterfly with wingspan greater than 17.5 as a previous part. Probably you can just stay with 0.0527, etc. Okay. So next one. The probability that n or more butterflies in a random sample of 36 Lorentz birdwing butterflies from town A are very large is less than 1%. So n or more. So it's more like a trial and error stuff. So let's say if I try a 10 here, if we try a 10, it's already less than 1%. So maybe we could try, let's say 5. Oh, 5 is close to 0.01, but it's greater than 0.01. So 6, 7. Well, I think the smallest value is 7 because when you go from 8, yeah, it's also the probability value is also less than 0.01. N is an integer. So what sort of things would constitute, some working out for 2 marks question? Well, I think a try and error will be perfectly acceptable, but you do need to put your answer in the more systematic fashion, okay? Write something like that. First, state what's provided in the question. We need probability L greater than or equal to N, less than or equal to 36. The probability itself is less than 0.01. And then we started with, stating the number of N we tried. Say for N equals to 5, we get a probability 0.03926, blah, blah, blah. Nope, not satisfying this one. N equals to 6, probability is 0.010659, dot, dot, dot. No, it's still larger than 0.01. N equals to 7, probability is 0.0024. Yes. N equals to 8, probability is even smaller. So that gives me N smallest equals to 7, okay? So actually, this is some sort of approach like a trial and error will be a suitable method or tabulation, okay? This is a similar idea to tabulation. Tabulation was actually a very famous and a popular method back in my time or even prior my time of doing VCE when we didn't have, this fancy CAS calculator. We only had, some graphics calculator or whatsoever. Okay, for random samples of 36 Lorentz birdwing butterflies in town A, p hat is a random variable that represents the proportion of butterflies that are very large, expected value and standard deviation corrected for decimal places. So expected value of p hat, large p hat, is your population proportion, which is 0.0527. It was the answer provided, okay? This is the population. Mean value is population proportion, okay? And Standard deviation of p hat, we probably need to use square root of p, 1 minus p divided by n. So it's a square root of 0.0527, 1 minus 0.0527 divided by the sample size 36. And using your CAS calculator, you are able to obtain that, which was, let me see, this was approximately 0.0372, okay? For decimal places. What is the probability that a sample proportion of butterflies that are very large lies within one standard deviation of 0.0527, correct, to 4 decimal places? Do not use a normal approximation. So this is like probability of p hat larger than 0.0527, subtracting one standard deviation, less than 0.0527 plus one standard deviation above. And bear in mind, p hat equals to the number of large butterflies, very large butterflies, divided by 36, x divided by n, in this case, L divided by 36. So you need to use 36 multiply 0.0527 minus the standard deviation, less than L, less than 36 times 0.0527 plus the standard deviation, etc. Okay? So you need to show some conversion from p hat to L. You need to convert your p hat to a discrete random variable, in this case, a binomial, because the question says do not use a normal approximation, okay? All right. So I'm going to get a range of values for L and then put the rounded value within for whole numbers and use a binom CDF, okay? And you could say, all right, I've got 36. Maybe let's do this. 36 times 0.0527 minus that. We don't need so many decimal places. Comma, 36 times. Bracket. Whatever you have here, put a plus in the middle. So it's like between 0.5 and a 3.2 something. So let's say by norm CDF, 0.556596, but it's larger than that, then it has to be starting from 1 for the discrete values, okay? And the maximum L value we can take is 3. So actually, what we are going to obtain is like a 0.7379666, etc. So to 4 decimal places, that will be 0.7380, okay? And that is probably the intention of the question. You convert the p hat into, binomial random variable with a suitable decimal range, your lowest value and R and the highest value. So let's complete the last part and then move on to the next page. Okay. So here I'm trying to be as specific as possible, trying to show every single step. But in practice, in the actual exam situation, you probably won't have sufficient time to do everything so perfectly. You can just, let's say, starting from here, and then showing the multiplication, and then maybe jump to here, or if you recognize a suitable range here, then you may just jump to your binomial CDF, okay? Because you have already defined the binomial random variable for at the start of part F, okay? You can see the whole question is about, let's say, a binomial distribution and also some sampling stuff, proportion, sampling proportion. And now lastly, an approximate 95% confidence interval for the proportion of butterflies that are very large was calculated to be this thing here. Created 4 decimal places, determine the sample size used in the calculation of this confidence interval. So remember, the confidence interval had, the lower bound is p hat minus z. For 95% confidence interval, you could use 1.96 or maybe 1.9599, okay? Something like that. Times. Well, this is your p hat 1 minus p hat divided by 30, actually not 36 because we don't know the n value yet. We have to figure it out. Okay. You can't assume n is 36. 36 was from for the last part, okay? And the upper is now the p hat plus 1.9599 times square root of p hat 1 minus p hat divided by n, okay? Equals to 0.0866. So you have a pair of simultaneous equations. And you can just solve this pair of simultaneous equations for the p value and n value simultaneously. So let's do this. Manual 371, we're solving for p and n. Let's just use p for p hat, okay? But p and p hat are different things. So just be mindful. 1.9599 times a square root of e times 1 minus p divided by n equals to 0.0234. And if you don't want to type out everything, you can just copy, hold the shift button and press right to highlight just this left-hand side, Control C, and go to the second cell, Control V. Put this as plus equals to 0.0866. Press Control Enter. You will see this n value can be rounded to the nearest integer because you can't have 0.93. Probably the feasible reasonable rounding expectation is 200, and the p hat is 0.055, okay? So the answer is 200 for the sample size. N equals to 200, roughly, is rounded from 199.93, etc. And p hat must be 0.055, okay? So that is the end of the probability question. And let's move on and look at the last extended response question. Okay, question 5. We are now using a simple function and some sort of investigative nature, investigative approach to go through these questions. Typically, this sort of question towards the end of the paper would have some parameter involved. In this case, it involves the tangent at x equals to a, all right, where a is between 0 and 1. So this is the main item we are analyzing upon. So firstly, find the equation of the tangent to the graph of f at x equals to a. Find the x-coordinate of q. So that's the x-intercept of this tangent found in part A. And find the x-coordinate of P. So we want to find the intersection point between tangent and, let's say, f of x, okay? So these are the parts. Now, we can actually do the 4 marks altogether by just using a couple of CAS calculator commands. So let's insert another problem and define f of x first. Define f of x equals to 1 minus x to the power 3, if I'm not mistaken. And let's call this tangent x, yt of x is assigned to menu 49, tangent line f of x, comma, x equals to a. So yt of x is this guy here, okay? So if you want to find the x-coordinate of q in terms of a, let's say we solve yt of q equals to 0 for q. So this is the x-coordinate for q, okay? And in terms of a, so let's say xq is equal to that. And x-coordinate of p, we can say solve yt of x equals to f of x, comma, x. So you can either get minus 2a and a here, right? So that's pretty much, the first 4 marks. Let's just transcribe everything back to the writing space. You can see I write the equation of line in the function form y subscript t of x minus 3a squared times x plus 2a cubed plus 1, okay? It has to be an equation, okay? Equation. And x-coordinate of q, let's say yt of x cubed equals to 0, giving you x cubed equals to pretty much 2a to the power 3 plus 1 divided by 3a squared, okay? It doesn't ask you for the y, so you don't need to specify y, but the y value, y of q is equal to 0, okay? X-coordinate of p. So let ytx equals to f of x. This yt refers to whatever you write here, okay? Be consistent. Throughout the question, I can use yt of x to represent the same thing for all other remaining parts. And that solves for x equals to minus 2a and x equals to a. But this is the tangential point x value. So you need to identify x of p equals to minus 2a. This is the one you want, okay? So that's like a 2 marks question. For example, some reasonable equating, etc. And then you get, x value, x expression, xp equals to minus 2a, okay? And let a be the function that determines the total area of the shaded regions. Find the rule of a in terms of a, and then find the value of a for which a is a minimum. So let me do a snippet here. Okay, you need to combine what you found in the previous parts. Say the coordinate of this p here was minus 2a. And the coordinate of Q here is 2AQ plus 1 divided by 3A squared. So instead of using, directly upper minus lower, because from many students, I could tell they're trying to use some sort of a splitting, like this line subtracting this curve from here to here. But then they will still need to deal with, another integration. So I'd rather you use, let's say, this height here is f of minus 2a, okay? So what I'm trying to do is I'm using this triangle to subtract the area under this f of x, okay? To get the shaded area. For example, the rule of a in terms of a is the integration of from minus 2a to 2a cubed plus 1 divided by 3a squared. What are we integrating? We are actually integrating the straight line, yt of x dx. This is the outer part. Subtracting from minus 2a to 1 f of x dx, okay? So once you get to this step, it's the triangle subtracting the area under the cubic, okay? Then you just slot everything into a CAS calculator and provide a lovely answer, okay? Even though the question was 3 marks. And then we trying to minimize this function. Notice that the a value is between 0 and 1. This is my domain. Let's say area of A is equal to, is assigned to shift plus minus 2a to this guy here, yt of x dx, subtracting an integral from minus 2a to 1 f of x dx. And area of A is this thing here. So you can just copy that down for part D. 80a to the power of 6 plus 8a to the power of 3 minus 9a squared plus 2 divided by 12a squared. And find the minimum. This is the value of A that gives the minimum area, but the question doesn't ask for the minimum area, okay? So let's say we could say a dash a equals to 0, and then you could say, okay, giving the value a equals to 10 to the power 2 over 3 divided by 10. Of course, for those Casio users, they will obtain some sort of equivalent answer to that, okay? And let's come back to, the writing space and look at the last two parts. Feels like this was a long exam from experience. It was a 2 marks question, and I would say, or use F minimum over this domain, okay? Right. Second last part. Consider the regions bounded by the graph of F inverse, the tangent to the graph of F inverse at x equals to b, where 0 goes from b goes to 1. B goes from 0 to 1, and the vertical axis. Find the value of b for which the total area of these regions is a minimum. Well, This is actually, you have to find F inverse and then the tangent. And also you need to determine the total area of this region and finding a minimum. There is a very smart method. For example, if you just using B equals to F of A value from the previous part, but that's a more, intuitive method. So what I'm trying to do is I'll go from scratch. Let's say solve x equals to f of y, comma y. This is my inverse function. Let's define the second tangent line like tangent line. That x equals to b. So yt of 2x is actually this guy here, okay? Now, this graph with b from 0 to 1. If I'm plotting the graph here, 1 minus x to the power 1/3. This is the inverse function. And if I'm using some slider here, let's create a slider and I click into -5 and 5. I'll change this to 0, change this to 1, and press Control menu. That's a right click setting. Let's use a step size of 0.05, etc. Okay. So when b equals to 1, that is actually giving you some undefined gradient. That's why it has to be, it has to be, for example, less than 1, but greater than 0. So actually, you can see what happens with the changing b value here, okay? You can see what's happening with the changing b value here. Let me hide the first equation. So the red line is the tangent from 0 to 1 within this region. Once you are changing the b value, you can see there will form two possible regions with the vertical axis here and here, okay? There are two regions, okay? Consider the two regions bounded by the graph of inverse and the tangent at x equals to b. Previously, this region is, this region will be identical to the region formed by the original and the equation x equals to a. Therefore, for the minimum area, we just need to get a b value via, okay, sub the value into the original function, 10 to the power 2/3 over 10. That's a math. That's the first method. Of course, if you were to find the area between these two regions, well, I will actually go from x equals to 0 and the intersection here. So you could actually solve this thing equated to that for x. So it's 9 minus 8b, okay? And looking at the diagram, upper function is the red line here, lower function is here up to 9 minus 8b. So 0 to 9 minus 8b. And yt of 2x subtracting, 1 minus x to the power 1/3 dx. So this is an expression involving b, and we want to minimize this expression. So area 2 of b is assigned to this thing here. Okay? And we can take the derivative with respect to b. Area 2b equal to 0 for b. 0 less than b less than 1. Oh, my calculator is stuck, but I suppose we could actually get a 9 over 10, okay? This is the same as that. So that's why they probably provided just 2 lines, okay? But to be honest, if you really want to get a clear idea of what's happening, instead of relying on some intuition or gut feeling, you really have to follow the following steps. 1, find the inverse function, which is very straightforward. 2, use the tangent line command to get the tangent to this inverse graph at x equals to b. So this thing here has a parameter b rather than a. 3, use a slider, or of course, if you want to avoid variable clashes. I'm not going to use b because I'll be using b for the future calculations. I'll use b1 instead of b, okay? 4, once you get an idea of what's going on, use the tangent line in terms of x and b, and also the inverse function to find an intersection here and find the area. Find the area, okay, of these 2 regions using upper minus lower. Don't worry about this touch point. You can just go from 0 to x equals to 9 minus 8b, etc. And finally, to minimize this thing, just use your calculus. Solve the derivative equal to 0 for b between 0 and 1. Of course, if you use this command, area 2b, comma b, 0 to 1. That gives you 9 over 10, okay? Immediately, instead of using derivative. So for the historical purpose, I'll try to put some detailed solutions here, okay? And finally, we want to find the value of the acute angle between the tangent to the graph of f and the tangent to the graph of f inverse at x equals to 1. So the tangent to the graph of f, let's say tangent line f of x, comma, x equals to 1. That's 3 minus 3x. And we would like to find, the angle between 3 minus 3x and the tangent to the graph of f inverse at x equals to 1. So there is a vertical tangent. This is the hardest part. This is indeed the hardest part of the question. So we're trying to figure out, let's highlight these 2 lines. Okay. So what you're trying to find is the angle between that and that, 3 minus 3x and 1. And of course, if you notice, this is just a 1 here, 1, and the y-intercept is 3. So you could use some sort of trigger ratio. Let's say theta equals to tangent inverse 1 over 3, or tangent theta equals to 1 over 3, whatsoever, okay? You could also express that as half pi minus tangent inverse 3, but the question wants an exact value. So you have to specify what's happening here, okay? You can use the alternate angle theory, or just construct, another right angle triangle. This is 1, this is 3. So the angle between the 2 straight lines is tangent theta equals to 1/3. So theta equals to tangent inverse 1/3, okay? Or half pi minus tangent inverse 3, or other equivalent expressions. I know there are other equivalent expressions, such as cot inverse of 3, but this is very rare to see, okay? Cot inverse is none of our business in math method. Okay, so for part F, intuitively, B equals to FA, and the A value was the one giving me the minimum area, 10 to the power 2/3 divided by 10. And B equals to 9/10, okay? To properly wrap that up, I'll probably include my methods here. Please see next page for a full method 2. Q5F method 2. I'll put a diagram here. So let's say this is 1, 0, and this is the inverse function, f inverse of x equals to 1 minus x to the power 1/3, okay? And the tangent is drawn at this point. The tangent has the equation yt2 of x equals to something using a CAS calculator, okay? And using your CAS, you are able to obtain this x value is 9 minus 8b, if I'm not mistaken. And the regions specified by the question is bounded by the vertical axis, the curve, and the tangent line itself. So actually there are 2 regions, okay? So the shaded region here, area of shaded region, let's call this A2 of B. It's the integration of 0. This is x equals to 0 to x equals to 9 minus 8b. And you have yt2 of x subtracting f inverse of x dx, okay? And use your CAS. F minimum, A2 of B, 0 to 1. Because it's either here, or let's say here. Okay, it forms, 2 different regions, but I want this region to be minimized, okay, etc., etc. And that gives me B equals to 9/10, okay? So that's another method. It's actually a combination of our CAS method and also, some strong algebra. Okay, hopefully you find this video somewhat helpful. I try to as specific as possible for historical reason and for my own learning and teaching backup resource building. And I'll find another time to complete all other previous method exam 2s, okay? Good luck with your exam preparation, and I'll see you in the near future. Bye.